Hello Chem 100, Dr. Tullis here. We are starting right with Chapter 1. Please be following along with the notes that are in your Canvas course. The first career that Chapter 1 looks at is a forensic scientist. Forensic scientist works in a crime lab, analyzes samples obtained from crime scenes, identifies the presence or absence of chemicals, including alcohol, illegal drugs, poisons, arson debris, or metals, and usually has a bachelor's degree, which include classes in math, chemistry, and biology. The first section is chemistry and chemicals, and our learning goal is to define the term chemistry and identify chemicals. The definition of chemistry is the study of substances in terms of composition, structure, properties, and reactions. What does that mean? Well, the composition is, what is it made of? For the structure, how is it put together? What characteristics does it have? And how does it behave with other substances? Chemistry happens every day. When food is cooked, a car is started, silver tarnishes, an antacid tablet fizzes in water, plants grow taller, food is digested. Tell me one of those applies to you. Chemicals are substances that always have the same composition and properties. All things you see are made of chemicals, like soaps and lotions, toothpaste, cosmetics, clothes, but chemicals always have the same composition and properties. Let's look at toothpaste, some chemicals that are in toothpaste. Calcium carbonate is in toothpaste, sorbitol, sodium lauryl sulfate, titanium dioxide, sodium fluorophosphate, and methyl salicylate. Notice the different functions. For example, calcium carbonate is used as an abrasive to remove the plaque. The sorbitol prevents loss of water and the hardening of toothpaste. The sodium lauryl sulfate is used to loosen plaque. So notice the function of each of the chemicals. Here's a sample problem. Which of the following are chemicals? Why don't you pause the video here so we can see. Glycerin is a chemical, water is a chemical, heat is not a chemical, sodium chloride is a chemical. The branches of chemistry is divided into, we have general chemistry, organic chemistry, biochemistry, geochemistry, and physical chemistry. In review, pause the video and make sure that you understand Section 1. Moving on to Section 2, we're going to look at the scientific method, thinking like a scientist. The scientific method is a set of general principles that helps describe how scientists think. Number 1, we make observations. Ask questions about what you observe. When an observation always seems to be true, it might be stated as a law that predicts that behavior is often measurable. However, a law does not explain that observation. We then form a hypothesis. Scientists form a hypothesis which gives a possible explanation of an observation or of a law. The hypothesis must be stated in a way that can be tested by experiments. 3, we need to design an experiment. To see if that hypothesis is valid, experiments are done to find a relationship between the hypothesis and the observations. If it's shown to be invalid, that means that it needs to be modified or just thrown out and start a new experiment with a new hypothesis. And then we draw a conclusion. When many experiments give consistent results, we can draw the conclusion that the hypothesis is valid. Even then, more experiments are done to test the hypothesis. Here is a summary of the scientific method. Everyday scientific thinking. Think about this. Here's an observation. Yesterday you went to visit your friend. Soon after you arrived, your eyes began to itch and you started to sneeze. You observed that your friend has a new cat. Here's a hypothesis. Perhaps you are allergic to cats. Experiment 1. To test your hypothesis, you leave your friend's house. If the itching and sneezing stop, perhaps your hypothesis is correct. If it does not stop, perhaps you have a cold. Observation. Upon leaving your friend's house, the itching and sneezing stops. So, the observation supports your original hypothesis. To confirm, go visit another friend that has a cat. Experiment number 2. Visiting a second friend with a cat causes your eyes to itch and you begin to sneeze again, further supporting your hypothesis. So your conclusion? The experimental results indicate that indeed you are allergic to cats. For each of the following, indicate whether the step of the scientific method is being described as an observation, a hypothesis, an experiment, or conclusion. Pause the video here. Hopefully you realize that by seeing that the blender does not work when it's plugged in, that's an observation. We have a couple hypotheses. We could say, well, the blender motor is broken or the plug has malfunctioned. Those are both hypotheses. We can do an experiment to see that the blender does not work when it's plugged in to a different outlet. And then the conclusion would be that the blender needs repair. Here's a little chemistry link to health. Paracelsus was a Swiss physician and alchemist who believed that chemicals and minerals could be used as medicine. Paracelsus determined that inhaled dust, not underground spirits, caused lung disease in miners. Isn't that crazy that people thought that there were underground spirits that caused lung disease? Thought that goiter was a problem caused by contaminated water, treated syphilis with compounds of mercury, and had the opinion that medicines with the right dose made the difference between being a poison and a cure. Here's a slide with a review of the learning goals from section 2, so if you need to pause to make sure you understand, go ahead. Moving on to section 3, we're going to identify strategies that are effective for learning and develop a study plan for learning chemistry. Learning chemistry. Well, first of all, chemistry is an intimidating subject, and a lot of people get scared when they have to sign up for chemistry. They think it's going to be so difficult. But really, if we have a plan, that's going to help so much more. So learning chemistry requires us to place new information into our long-term memory and to remember those ideas for an exam, which is called retrieval. So our study habits help us to recall knowledge. Number 1, do not keep rereading your notes over and over and over and over again. Reading that same material will make that material seem familiar, but it doesn't mean that you've learned it. You need to test yourself. Go over practice problems. And there's a ton of resources in your book at the end of the chapter that will help you do so. Ask yourself questions as you read. There's the engaged features in the margins, and they're helpful in asking you to think about new material. Do some self-tests by giving yourself quizzes. And there are sample exams. Practice taking these tests frequently. Study at a regular pace rather than cramming the night before. So spread it out. Hopefully in your study plan, you are planning to do your chemistry homework over multiple days and not just on Saturdays and Sundays. Oh my goodness, sleep is also important for strengthening the associations between newly learned information. Lack of sleep will interfere with retrieval of information. Number 5, study different topics in a chapter and relate the new concepts to concepts that you already know. Looking at your text features, there's a looking ahead, which is the outlines the topics in the chapter. Each have learning goals. There's review icons in the margins that refer to the key math skills or the core chemistry skills from previous chapters. There are key terms that are bolded when they first appear in the text, and then they're summarized at the end of the chapter. And they're also in the glossary and the index at the end of the book. We have key math skills and those core chemistry skills that are critical to learning chemistry, indicated by icons in the margin and summarized at the end of each chapter. There are lots of sample problems in each chapter. So do. The try it first feature reminds you to work the problem before you look at the solution. It's easy to cheat and go right to the solution. Don't do it. It's not going to help you. At the end of the chapter, there's chapter reviews, concept maps, understanding the concepts, additional practice problems, challenge problems, tons of resources. You're also going to see chemistry links to health and the environment, which relate chemical concepts to real-life situations. Those are also really interesting. And then there's figures and diagrams that show the macro to micro illustrations depicting the atomic level of organization, like the atoms that are in aluminum foil that you use. Again, we've got practice problems after each section, and there's also interactive videos to help look at concepts. So you're going to make a study plan. These ideas are ways to successfully learn chemistry: reading the chapter before class, going to class. Now granted, we have a hybrid class, so going to class will be going to your labs, reviewing the learning goals, keeping a problem notebook, reading the text, working the practice problems, answering the engaged questions, trying to work through some sample problems before looking at the solution, studying different topics at the same time, organizing a study group, maybe somebody from lab, seeing the professor during office hours. I welcome you to come to office hours, reviewing the key math skills, the core chemistry skills, attending review sessions, and studying as often as possible. Why don't you pause the video here real quick? State whether each of the following activities is part of a successful study plan. Do you agree with these answers? This summarizes the section, so be sure to look at that learning goal and see if that's addressed. Let's look at section 4, key math skills for chemistry. Our learning goal is to review math concepts used in chemistry, like place values, positive and negative numbers, percentages, solving equations, and looking at line graphs. We are going to be working on identifying place values. If this is where a decimal point is, To the left of the decimal point, we have our ones, our tens, our hundreds, and our thousands. So this would be 482. And then to the right of the decimal point, we have our smaller, our tenths, our hundredths, our thousandths. So this would be 482 and 57 hundredths. The name of the place value for a digit depends on its position relative to the decimal point. The place values increase by 10 moving to the left and decrease by 10 moving to the right. If I looked at this number, 2518 kilograms at a crime scene, that much illegal drugs was seized. That'd be 2,518. That's the thousands. They're all left of the decimal place. 2518, the decimal would be right there. A bullet fragment has a mass of 6.407 grams. So this is my ones. This would be tenths, hundredths, thousandths. So 6 and 407 thousandths of a gram. Using positive and negative numbers in calculations. A positive number is a number that's greater than 0. It has a positive sign. Or it might not have a positive sign. It might be lacking. It might just be written as just 8, for example. But a negative number is anything that's less than 0. It will have a negative in front of it. There is no or. Like this says, it can be plus 8, or it's also written as 8. If it's negative, it's always got the negative in front of it. Now when I multiply with positive and negative numbers, when two positive numbers or two negative numbers are multiplied, the answer is positive. 2 times 3 is 6. Negative 2 times negative 3 is 6. And again, that plus sign is understood. You don't have to write plus 6 as your answer. You can just write 6. Now when a positive number and a negative number are multiplied, the answer is negative. It can be 2 times negative 3 or negative 2 times 3. Still get negative 6. When we divide with positive and negative numbers, the rules for division are the same as those for multiplication. So if I have two positive numbers, 6 divided by 3 is 2. Negative 6 divided by negative 3 is also 2. So both positive or both negative. If I have one positive and one negative, negative 6 divided by 3 is negative 2. 6 divided by negative 3, negative 2. So one of those was positive and one of these was negative for this example. When I add positive and negative numbers, the sign of the answer when two positive numbers is going to be positive. 3 plus 4 is 7. Again, that plus is understood. When negative numbers are added, this answer is always negative. So a negative 3 plus a negative 4 is negative 7. When a positive number and a negative number are added, the smaller number is subtracted from the larger number. And then the sign is the same as the larger number. So 12 plus negative 15 is going to be, the larger number here is the 15, so we have the sign is negative. And we would do 15 minus 12 to give us 3. When two numbers are subtracted, change the sign of the number to be subtracted. Follow the rules for the addition of positive and negative numbers. So 12 minus a positive 5 is the same as 12 plus a negative 5. So that's 7. Versus negative 12 minus a negative 5. If you minus a negative, you add. So negative 12 plus 5, which would be negative 7. To find a percentage, you divide the parts by the whole, or by the total, and multiply by 100%. So if an aspirin tablet contains 325 milligrams of aspirin, which is an active ingredient, the tablet has a mass of 545 milligrams. What's the percentage of aspirin in the tablet? Here's my aspirin, my part, divided by my whole, and times it by 100. So the tablet is 59.6% aspirin. Double check with your calculator. Let's say that I was told that there was 5% of all of the balls somebody had were red balls. Well, saying that something is 5% is saying that 5 out of 100 balls are red. Let's say I had a bucket of balls and 50% of them were green balls. I can also take that percent and say, okay, well, if that bucket had 100 balls, then 50 of them would be green. Let's rearrange equations to solve for x. Hopefully this is review. If I have 2x plus 8 is equal to 14, I need to get rid of this plus 8, so I'm going to subtract 8 from both sides. You can see here that they subtracted 8, leaving us with 2x is equal to 6. And then to solve for x, I got to get rid of that 2. Right now, the 2 and the x are being multiplied by each other, so we need to divide by the 2 to get rid of it. 6 divided by 2 is 3, so x is equal to 3. Then you always need to go back and check. Go back and replace that 3 into the original equation. So 3 times 2 is 6 plus 8 should give you 14.